Let us start. In previous unit, we discussed about the Warner's theorem, and there are the structural isomers. Now, there are applications or some questions given below. Test to distinguish between CuNH3 Br SO4 and CuNH3 SO4 Br. These two types of isomers are called ionization isomers. Distinguish between them is the test here SO4 minus 2 is outside the third bracket, so it gives the reaction of SO4 minus 2. If we add BaCl2 solution in both these cases, BaCl2, first one is BaSO4 solution, BaSO4 precipitation is occur, which is white in color. In first case, BaSO4 precipitation occurs white in color, but in second case, if we add AgNO3 in this solution, AgBr precipitation, that is yellowish in color, AgBr precipitation here occurs, but here BaSO4 white color precipitation occurs. It is the distinguishing between them. The another one is CrH2 Cl3 and CrH2 Cl, Cl2.H2O. These are generally hydrate isomer. These hydrate isomer can be distinguished between between them is one experiment is solution of AgNO3. If AgNO3 is supplied, both of them, there are 3 Cl minus present outside the third bracket, so AgCl precipitation is 3 molecule, and here number of Cl is 2, so AgClB there are 2 molecule. It is one experiment, and the another experiment is conductance, that is number of ion. Here the number of ion is 1 cation and 3 anion, that is number of ion is equal to 4. But in case of the second, here number of ion is 1 cationic species and 2 anionic species, so total number of ion is equal to 3. So ionic conductivity here increases as the total number of ion increase, that is 4, and here number of ion total is 3. Let us discuss question number 3. Here the distinction between cis PT Cl2NH3 and trans PtCl2NH3. There is only one distinction between them, is experiment is dipole moment. Here the cis element dipole moment is equal to 0, but in is not is equal to 0, but in trans the dipole moment is equal to 0. So dipole moment is the specific and the distinguishing experiment between them. The another question is PtNH3 Cl2 and PtNH3 Cl2. Here the number of ion is how many number of ion here? There is no number of ion. It is non-electrolyte. PtNH3 Cl2 is non-electrolyte. As the number of ion, there is no number of ion. Pt is plus 2 and Cl is 1, Cl is minus 1, so the charge balanced by plus 2 and minus 2. There is no number of ion forms, that is it does not act as electrolyte. But in PtNH3 Cl2, the number of ion outside the third bracket is 2Cl. So if we add AgNO3, both this solution, both this compound dissolved in the solution, there is no AgCl precipitation, but here 2 AgCl be precipitated. That is the another experiment for their distinguishing. Question number 2, greater molar conductivity, which has greater molar conductivity, K4 FeCN6 or K3 FeCN6? It is also discussed in early that number of ion, that is the total number of cation and total number of anion. K4 FeCN6 here number of ion is equal to 4K plus, that is total number of cation is 4 plus anionic species is FeCN6 minus 4. Fe is in plus 2 oxidation state, so number of ion is anion is 1, total number of ion is equal to 5. And the second part is K3 FeCN6 K3 FeCN whole 6. Here 3K plus, that is 3 cationic species, and FeCN whole 6 minus 3. Here Fe is plus 3 in oxidation state. So number of anion is 1. So total number of ion is equal to 4. Here total number of ion is equal to 5, and here total number of ion is equal to 4. So the greater molar conductivity is K4 FeCN whole 6 is the highest molar conductivity. Molar conductivity between them. Write hydride isomers of CrH2 whole 6 Br3 and order of conductance. According to their order of conductivity, they must be arranged. So hydride isomers of CrH2 whole 6 Br3 is written as there are so many hydride isomers. One is CrH2 whole 6 Br3. Another is CrH2 whole 5 Br2 dot H2, CrH2 whole 4 Br2 Br dot 2H2, and the another is CrH2O whole 3 Br3 dot 3H2O. These are all hydride isomers of CrH2 whole 6 Br3. Let how their conductivity varies and which has better conductance, and arrange them according to their conductivity order. Here the total number of ion is 3 Br minus, so anion is 3, and cation is only one cationic species, that is the third bracket present in this third bracket, one cationic species. Here the number of cationic species is 1 and number of anionic species is 2. Total number of ion is equal to 3, here total number of ion is equal to 4. Here total number of ion is cationic species, and this is cationic species, and anionic species is just Br, means one anionic species present, Br minus. So the total number of ion is equal to 2. Here it is non-electrolyte, that is number of cation and anion cannot be formed. So according to their conductivity series, if we arranged it is highest in among them, it is the highest in conductivity series. Then this after this, and at last the CrH2O3Br3.3H2, as it is not electrolyte, there is no cation or anion formed, there is no anionic or cationic species present. So it is, if we represent 1 2 3 4, then 1 is greatest, then 2 3, and after that is 4. So lowest is 4 and highest is 1. 4, coordination number 4 means the central metal ion attached with 4 number of ligands. For example, Ma2B2, here M is metal ion and A one type of ligand and B is another type of ligand. Example is PT NH3 whole 2 Cl2. Here two types of stereoisomers or geometrical isomers form. One is cis, another is trans. PT Cl NH3 is the cis form, and the other is the trans form is PT Cl NH3. This is the trans form. So it is Ma2B2. Another is Ma2BC, where A is one type of ligand present twice, B and C different type of ligands. So for example, here PT Cl2 Bri, M A to BC. M means central metal ion. B to here A2 is to Cl. B is one type of ligand and C is another type of ligand. It is the cis form and the transform is PT Cl Cl I Br. It is the transform. Here it is to be also noted that in case of M AB whole 2, MAB whole 2, AB is a bidentate ligand. Ligand denticity of the ligand we already we discussed later, but the denticity here, the denticity of the ligand is 2. AB is one type of such example is glycinato. Glycinato. Glycinato means come from glycinate. Glycine is the CH2 NH2 COOH. Glycine, one type of amino acid. That COOH when releases hydrogen H plus, this form is NH2 CH2 CO minus. That is the glycinato. Here reacts with PT or PD. If we react with PT, then two types of isomer formed, PT COO minus, here two donor center, O minus, that is one negative donor center, as well as N neutral donor center. So the denticity of this ligand is 2. But here AB means different donor center. One is nitrogen and another is oxygen. So different donor center, in case of different donor center, here represent it is AB. If donor center be same, such as EN, ethylene diamine. Ethylene diamine example is CH2 CH2 NH2 NH2. Here it is also didentate ligand, but the denticity of the ligand both are 2, but it is AA type of ligand. AA type means here the both the donor center are same, but here the donor centers are different, so it is represented as AB. Now in case of platinum when reacts with glycinato ion, two glycinato ion, so there are two types of geometrical isomers, cis and trans. O C double one O CH2 NH2 and the other is NH2 CH2 C double one O C double one O. Here it is the cis form of platinum reacts with when reacts with glycinato ion, and the other is transform. Here PT. Transform means N represents anti to each other. N, here N, O, glycinato. Anyone can represent it by GLY or just this like of structure, but it is very easy or very simple that if we represent it GLY, at the donor center is N and O, though both the donor center N are anti to each other, so these are called trans, and if they are besides, so it is the cis form. It is also represented as, here it is also represented as PTNONO. It is also cis form, glycinate, and it is the trans form. There are another type of coordination number 6. Coordination number 6 means octahedral system. It is for tetrahedral system, and now we discuss the isomers in octahedral system. That is, in case of octahedral system, coordination number here is equal to 6. One type of isomer presence is A. Let us take the geometrical isomer for coordination number 6. At first, Ma4B2. Ma4B2 means CONH3 whole for Cl2. There are two types of isomer present: CONH3 whole CO, NH3, 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 NH3. One is Cl, another Cl. So it is transform. Two Cl are possesses anti to each other. It is called transform, and the another is CO NH3 NH3 Cl, Cl, NH3, NH3. Here the Cl and NH3 are in empty position, so it is called the cis form. In trans form, same type of ligand or same type of group is opposite to each other in trans form, and the another is cis form. Here different type of ligands or different type of molecules are bonded to to each other. Here one example is A3B3 or CONH3 whole 3 Cl3. These are given below. We represent this CONH3 whole 3 Cl3, CONH3 whole 3 Cl3, that is one Cl and another Cl. It is actually it is transformed, but its name is mar, and one is fresh, that is cis form CO Cl 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 NH3 NH3 NH3. It is actually cis form, so it is fresh. The two types of isomer here in A3B3 present. One is anti to each other, that is one like a transform, it is called mar. It is also a transform, but we can represent it by mar. And the cis form, where cis form anti to each other different group, that is called cis form. Here cis form we cannot write it cis, it is to be written as FAC or face. So in A3B3 done in A4BC, in case of A4BC, CONH3 H2O Br. Here two cis and trans, CONH3 NH3 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 H2O and Br. It is transformed, and the cis form is CO NH3 Br NH3 H2O NH3 NH3. Here the H2O and Br, these two groups are anti to each other, it is called transform, and here it is cis. The another is MAA whole to A2, or AA means a bidentate ligand, but the donor centers are same, so it is represented as COEN whole to Cl2. Let us take the picture of COEN whole to Cl2. COEN whole to Cl2, COEN, ethylene line, that is called EN. One Cl is upper and the one is lower in case, but COEN whole to Cl2, it is transform. Transform is optically inactive. Whether it is optically active or optically inactive, it is in class 11 that generally chiral carbon present maximum percentage is optically active, but major important part is sigma plane or plane of symmetry present or not. In case of MAA whole to B2, that is COEN whole to Cl2, it is the transform, that both Cl present are anti to each other, that is transform. It is optically inactive as transform, optically inactive as there is a sigma plane present. This type of plane is called sigma plane, where both the right and left be same between a mirror. So it is called the optically inactive, and it is transform. And another is cis form, where Cl both the two Cls are not in anti to each other. Between the any type of position which is not anti to each other, that is called the cis form. And the cis forms are, if we mirror placed in between them, and these two are non-superimposable mirror image. Non-superimposable mirror image means it is not superimposed to that, and so it is called enantiomers to each other, that is plus minus form, and it is optically active. One is optically active as whether it is or it is, there is no sigma plane present, and the optical activity shows if there is no sigma plane. If there is a sigma plane or plane of symmetry, so it is optically inactive in case of transform. But if MAB whole 3, that is CO glycinate. Glycinate means two donor centers are different. One is O and the O minus, and the other is N. here, but in AA means two donor centers are same. So En means ethylene diamine, both the donor centers are nitrogen neutral. But in AB whole 3 means GLY whole 3 glycinate ion, here the donor centers are different. One is O minus and the other is N. Here, if both the O are present at anti to each other, it is called the transform. And if both O are not anti to each other, that is in anti position, one is O and the other is N. That is, it is GLY glycinate, it is GLY glycinate, it is GLY glycinate, GLY glycinate. So it is the transform and it is the cis form. Now we discuss